You're listening to the STEMxm podcast, highlighting women in the fields of science, technology, engineering, and mathematics. And now, your host, Mel the Engineer.
Hello, and thank you so much for tuning in to listen today to episode 19 of the STEMxm podcast. This is the third in a series on water and wastewater careers. Today we have Emilie Moore joining us. Emilie has over 25 years of experience in civil and environmental design and consulting. And Emilie has special expertise in drinking water treatment. So Emilie currently works as a senior project manager and an area manager for a consulting firm in the Tampa region. She has a BS in environmental engineering and a master's in engineering management. Let's have a listen to what Emilie has to share, and I'll be back with you at the end to chat about show notes. Emilie Moore, thank you so much for joining us today on STEMxm.
Well, thank you for having me. Appreciate it, Mel.
Absolutely. It's my pleasure. So we're going to talk about your career today, and I want to start with some questions about really early in your life. So could you tell us where you grew up?
I grew up in Gainesville, Florida. I'm a native Floridian and grew up right there in University of Florida land. I'm a true Gator. And love the state of Florida, having grown up here.
And when you were a child, was there any aspect of math or science that you were particularly fascinated by?
I was fascinated by the solar system, and related to that, I was fascinated by the NASA program. And I just loved going to Kennedy Space Center and reading about the astronauts and the missions, and that is a very, very warm and very vivid memory from that time.
Okay, so you ended up in a field that's quite different. What point did you know that you wanted to go into some aspect of engineering? Like how did that happen? Were you in high school, or did you get to college and try some stuff? How did that work?
It started in high school. I have a cousin who is about 12 years older, and he was studying, well, it's more of, say, environmental sciences, and there's a engineering theme to it. He was studying more about like nuclear engineering and protecting workers from exposure to radiation. And I was very fascinated by the work he was doing. And then I'm just very attached to the earth, and was reading a lot about different environmental cleanup sites throughout the country growing up. So in high school, I made the commitment that I wanted to do something to help clean up the earth, and it seemed like the environmental engineering route was the best path forward to get there.
Okay, so you decided to study environmental engineering, and did you go to UF or did you go somewhere else?
Yes, I got my bachelor's from UF in environmental engineering.
Okay, and did you do any internships or co-ops while you were there?
I did. I actually interned at a consulting firm in Fort Myers for a summer while I was in college, and that was a very good experience. It was a good time to learn how that business works, the pace of it, the types of work that you start off doing. So that was a very great experience. I suggest, if anybody can do at least one internship, I think that's a good decision.
Okay, so tell us a little bit more about that. What was your experience there, and what did you get out of it?
I learned a lot about, a lot about actually like the dynamics within an office. Everybody had a role, and I was only there for 3 months during the summer, so it was learning, how they were incorporating me into working on a project, and trying to make it fun as well. But there's some things that we all start off doing, working on design plans and working on specifications for design. So it was good. It was showing how the training in school could be applied to the consulting world. Also, getting some exposure to some of the clients that the team was working with was also another good experience during that time.
Was there anything that surprised you about working in the world of consulting? And what type of, you mentioned, what your cousin was working on. So what were you working on there? Was it municipal water and wastewater stuff?
Well, with my cousin, he was more involved in more like monitoring radiation exposure to workers at different facilities. So, say if it were nuclear power plant or a facility that handled different materials that could emit radiation, that was the area he was working in. And I did some work with him, but that area of the business. I mean, they're very careful, so I was not allowed to do some of the radiation monitoring he was doing. The internship I was doing in Fort Myers, that was with a company that focused on water, wastewater, reclaimed water, and stormwater projects. And so definitely got some exposure to the specifications for different projects. Learning how the company was working on a very large integrated water resources project at the time, and so learning about different uses for water, in this case for reclaimed water, that was good exposure with that consulting firm in Fort Myers.
Okay, so I want to get into a little bit of the science-y part of the work that you do with different types of water treatment and what you just mentioned, uses for reclaimed water. But before we do that, can you walk us through a little bit of what happened for you after that internship? So you finished your bachelor's degree, and then what? Did you continue in consulting, or did you do something else?
Yes, I did continue in consulting. And before I did that, the next summer I did work in Yosemite National Park for the summer. So that was a fun, fun adventure.
Yeah.
So I do, yes, I do recommend if people can take a little bit of a break, it's good, because otherwise, yes, once you get to working, there's a lot of rewards, but there are a lot of demands on your time to get the experience, and to just, you don't have the opportunity to take a whole bunch of time off, when you're first working. So once I graduated from college, I moved to Tampa, and the firm I was working for focused mostly on leaking underground storage tanks. So that path was evaluating the different sites, and then developing different treatment systems to treat the groundwater and the soil that had been impacted by these leaking tanks, leaking diesel fuel, unleaded gas, etc. So so the path at that time was more along the lines of the environmental cleanup type activities, and that line of work continued for approximately the next 4 to 5 years, and then I found my way back to water, wastewater, and reclaimed water treatment.
Okay, so just to get a little bit better visual, when there's contamination like that from a leaking underground storage tank, that's usually something like gasoline. So could you describe for us, just in real general terms, how an engineer would go about making a design to clean that up? What does that entail?
Well, for the sites that say were impacted both, um, both the soils and the groundwater were impacted by the gasoline or the diesel fuel, then in the early days, there's a lot of focus on installing groundwater wells and then pumps to try to draw back the contaminated groundwater. And then once that water was out of the ground, then to treat that water, a lot of times with different types of air stripping processes. And for the soils that were contaminated, trying to get air. So we would have points in the soil where we would try to draw air out of the soil and try to vaporize the hydrocarbons from the soils. And then as the treatment technologies got more advanced, there were different technologies with using steam, injecting air, using different types of chemicals and biological products to treat the soils. So it was dealing, designing different pumps, whether they're water pumps, or designing different types of air blower systems, the different types of air stripping towers, the different pipeline sizes to connect the different systems. So those were all incorporated in these designs.
Okay, great. Thank you so much for explaining that to us. So I'll just tell the listeners right now that Holly Nelson, in one of the previous earlier episodes, she spoke a little bit more about some of these types of more technologically advanced cleanup methods that Emilie just mentioned. So, yeah, thank you for explaining that, Emilie. So going on from there, you said you kind of made your way back. What did that look like? Were you ready for a change, or did an opportunity kind of present itself?
It was the opportunity, and it seemed the timing worked very well. There were more jobs in water, wastewater, reclaimed water, and stormwater. So, fortunately, I was working with a company that had a wide variety of projects to work on, and just looking forward into the future, it just seemed that that was going to be a better area of engineering to follow. And so fortunately, having the environmental engineering degree from, in my case, University of Florida, I was able to be able to, transition into that arena with a lot of support from mentors, from senior engineers and project managers that had been in the business for many years.
This is the STEMxm podcast with Mel the engineer.
Had you already earned your professional license at this point?
I did earn it just about the same time. And well, I guess for those listeners that are looking to take their professional engineer's exam, that in my case, I decided to take the civil engineering exam versus the environmental engineering exam. The environmental exam was somewhat in its infancy by the time, about the time I took the PE exam. So I decided to get my license in civil engineering.
Okay. And then over time, you've developed expertise in drinking water treatment. Could you talk to us about how that unfolded? Was that something that you actively pursued, or were you just like with a company that won these projects?
It was a little of both. I think though, more primarily with the company winning different work, that certainly gave the opportunity to work on these projects. So, having the background from college, and then the working background, and then also the senior staff that that I was teamed with, that we well, basically just starting working on smaller systems, say working on chemical storage and chemical delivery systems that are part of the water treatment process. And then as you gain that experience, and then expanding that to looking at more advanced water treatment processes as part of a treatment plant design. So it's a twofold approach, or opportunity, where the company was winning work, the exposure was there, and then I just kept having those opportunities and was able to expand my experience.
Okay, so I want to get into some of the basics of your field. First, I wanted to ask, did you ever go to work for a municipality directly, or have you been in design pretty much the whole time?
Yes, I've been in design. I've worked with consulting firms my entire career.
Okay, okay, great. So for our listeners, could you tell us what the main sources of drinking water are that a municipality will pull from?
As many people know, it will vary based on the region of the country you live in, or where in the world you live. Dialing into Florida, then many of us still tap into the groundwater as the source of raw water supply. There are systems that do use surface water, whether it be, say, river water or seawater for supply. And um, there, so well, and I think one of the important things is that the economics of water are very important. So um, over the past many years, groundwater has been the least expensive source of supply for many municipalities. But then as time has gone on, then those municipalities might be looking at, say, they might still be looking at groundwater, but maybe it's, say, brackish water, and then that requires treatment that's more expensive. For surface waters, the fresher surface waters will be less expensive to treat, and then looking at the seawater sources, as many people are familiar, just due to the nature of having to treat that water for drinking purposes, that there's a lot of processes, there's a lot of energy that's consumed in creating potable water from seawater. So that's kind of it in a nutshell. At least here within Florida.
Okay, so when you say the economics of it, you're kind of talking about the cost to treat. So the cost to get it to a point where it's drinkable or potable, and we can send it out in the supply system. So correct me if I'm wrong. It sounds like the gradation that you just described, the cheapest is typically groundwater in terms of treatment, and then if you go up from there, more expensive treatment would be required for surface water like lakes and rivers and brackish water. And then the most expensive would be like seawater, ocean water.
Yeah, that's a good rule of thumb. And then what we're seeing some of in Florida and then across the country and in parts of the world that recycled water or reclaimed water is being treated. It's called potable reuse. So that is becoming um, a source of supply. And it just, depends on some factors. In some cases, it is less expensive to treat the reclaimed or recycled water to potable quality versus treating a seawater to potable quality.
Okay, and can you tell us a little bit more about that? Have you worked on a design that used this?
Right now, yes. Currently, there's a team of engineers, architects, hydrogeologists that we are working on a project that is a potable reuse project in Florida. And so the idea is to take up to 4 million gallons a day of reclaimed water and purify it to better than drinking water standards, and then to introduce this purified water into the aquifer. So in this case, it is an indirect potable reuse application.
Okay, and some of our listeners, they might know that reclaimed water is what's in the purple pipes. So what you're describing is instead of taking that and doing something like irrigating lawns with it, we're taking it and treating it to a very high standard of quality and reusing it. So you described indirect potable reuse, and that just means that it doesn't go directly to a drinking water treatment plant, right?
Correct.
But it's going somewhere where eventually, after being touched by nature, so to speak, it'll be pulled out as a source.
Correct. Yeah. And there's a large system in California that has been operating an indirect potable reuse system for, I believe it's over 20 years now. So, and then there are systems in the world that have also been operating for long periods of time.
Right. So could you tell us some of the main processes at a drinking water treatment plant that water goes through? Talk to us about the processes that make it safe for human consumption.
The drinking water treatment process is many times is typically more physical and chemical treatment processes. Some people may be familiar, say, with like with wastewater treatment, it's more biological treatment processes. So that is one distinction between those two types of processes. With drinking water treatment facility, if like on the higher end, some of the more advanced treatment processes may involve different types of filters, membrane treatment, maybe involves ozone treatment or ultraviolet light UV treatment. So, the more advanced side of water treatment can go to that degree. And then some of the treatment processes that are less expensive, say, would use groundwater as a source of supply. And in some cases, some facilities could operate where the groundwater is removed, and then it would be, say, disinfected with, and the listeners, they know bleach, so it would be disinfected with chlorine and then it is safe to drink to the consumer. So, and just to also clarify with the advanced treatment processes, that those processes still need a disinfection step as the last step. So, um, there's some similarities to the say more simple processes versus the more advanced processes, and definitely looking at disinfection of the water before it's delivered to people's taps, and that water has to have some type of disinfectant residual in the water. And to clarify, a lot of communities, they can use chlorine. In the Tampa Bay area, there are a lot of us that utilize chloramines, but the message is still the same, that the water is being disinfected before it reaches people's taps.
Okay, could you talk to us for a minute maybe about some of these different disinfection options and what the benefits of these different options are? So you mentioned chlorine and chloramine and ozone. Could you just tell us, how those work and in what situation we might use one over another?
A lot of times, well, and I think this is a message that a lot of people will appreciate, that for the different utilities, and say private or public utilities that are delivering potable water to people's taps, that they're trying to do this in a very cost effective manner. So if the opportunity exists that a utility, they can disinfect the water, say with chlorine, and it's done safely. Disinfection byproducts are not being created. Then, in many cases for utilities, that might be the least expensive and safe option to deliver, potable water to the consumer.
I want to
And
pause you right there and ask you to tell us what's a disinfection byproduct.
well, with disinfection byproducts, they can be formed if a water has organics in it. So you can think of carbon as organic, and a disinfectant can react with the organics in the water and create byproducts that at certain levels, um, that we don't want to drink. So if say sometimes, in particular, say for surface waters, the source of the water is a surface water, you are likely going to see higher levels of organics in a surface water than, say, you would see in a groundwater. And if if you were to take that organic laden water and treat it with chlorine, just straight bleach, that you can form these disinfection byproducts at levels that um, that we were not going to drink. They are above the regulatory limits. So in cases like that, where you might have water with higher organics, then chloramines, which is a mixture of chlorine and ammonia, could be utilized to um, have less disinfection byproducts at lower levels be formed when the disinfectant is reacting with the water. So, and to point out that much of what we do in this industry is based on meeting the regulations to keep the water safe for the public. So, whatever it takes to keep the water safe, for the water to meet the primary and secondary drinking water standards, that's the charge of, myself, of other people in consulting, of the private and public utilities that are producing this potable water. So it has to be safe for the public, and we take that very seriously.
Hi, everyone. This is Mel, and I wanted to take a pause in the interview right here. It's difficult to cover all of the technical aspects of drinking water treatment in a short interview like this. So I wanted to make sure we mentioned that a typical drinking water treatment plant has multiple process steps that make our water safe. Common processes that drinking water sourced from a lake or river might go through at the treatment plant include coagulation and flocculation, which is where chemicals are added to help particles suspended in the water to clump together and settle out. And then the water goes through a sedimentation step where it's given time for all of the flocks or particles to settle out, and they're removed at this step. There could still be some tiny particles suspended in the water at this point, so then the water would go through a filtration step. And a final step would be disinfection. So like we mentioned, this could be with free chlorine, chloramines, or ozone, or sometimes even a combination of ozone and then a chlorine product added at the end, so there's a residual disinfection power in the water as it travels through the distribution system or pipes before it gets to your house. So there are a couple of other steps your drinking water treatment plant might take, such as fluoridation or adding corrosion inhibitors. So this is a really complex topic, but all interesting and, of course, very important. So if you want to learn more, be sure to check the show notes where I'm putting links to several great resources. Okay, now let's get back to our chat with Emilie about drinking water treatment regulations. Who develops and enforces these regulations?
The regulations have come from the federal government, through the Environmental Protection Agency, the EPA, and EPA is on a regular basis studying these different chemicals that can be in water, and they are always looking to see if they need to adjust different primary and secondary drinking water standards to keep the public safe. Within the state of Florida, the Florida Department of Environmental Protection has the charge to enforce primary and secondary drinking water standards as stipulated by the EPA. And it's been like that. Our Florida Department of Environmental Protection has been the enforcement agency for many years. In some areas, there also could be departments of health, DOHs, that may have the permission from the FDEP to enforce the regulations. In some cases, they can review the design plans for a water treatment facility, and then they would also be allowing or granting a permit for the construction of such a facility. So, so just to say, some places in Florida, they may have kind of this like third layer of enforcement. So it lends to the discussion that our drinking water is highly regulated before it gets out to the public.
Thank you for explaining that. So I just want to point out that we're recording this in the first quarter of 2017, and this is a bit of a strange time in the U.S. With respect to environmental regulations. As a professional, do you have any concerns about anything around public health with respect to what's happening politically?
Well, I think an important message is that first and foremost, the public health is our primary charge. And, for, many years, over 100 years that we have been providing safe drinking water to our citizens. And, we are always making sure that if, say, for example, in this day and age, there are a lot of pharmaceuticals in our environment, and we need to make sure that the pharmaceuticals are being tested for and are not ending up in a potable water that at levels that are would be unsafe to the public. So, um, having the our professionals in water treatment stay on this path of testing for and trying to keep up with the emerging contaminants, pharmaceuticals, personal care product, chemicals that are getting into our environment. That is very important to ensure that if treatment to remove that chemical from the potable water is necessary to produce a safe potable water, that it's very important that we make that happen. So, um, you know, we need to keep pushing as we have been over, I'd say, the last 40 years to be keeping ahead of, um, what chemicals we need to be removing from the potable water.
You brought up something really interesting, so I'd like for us to expound on that a little bit. So you're calling pharmaceuticals emerging contaminants. And so for listeners who are not in the environmental field and are not familiar with this topic, can you kind of walk us through, how do the pharmaceuticals end up in the environment and then potentially in a drinking water source? And then once that source water comes into a drinking water treatment plant, what could happen at that point? Do the pharmaceuticals pass right through all the treatment processes, or is there something else that happens? Could you walk us through that?
Sure. And let me say, right now, with the levels of pharmaceuticals in, most of the places that I've seen, that they're at such low levels, at say nanograms per liter, that it would take consumption of thousands of gallons of water a day for somebody to receive the medicinal dose for that pharmaceutical. Um, they are getting into the environment. The biggest path is actually out of the human body, because I think probably many listeners do understand that when you ingest a pharmaceutical, you are not going to use all of it in your body, and then you're going to discharge the pharmaceutical. Obviously, that's going to end up in the toilet. It ends up in the wastewater. And it's important that people, they don't throw their old pharmaceuticals, medications down the toilet and flush them. I think most of us know there are programs to safely dispose and properly dispose of your old medications. But the biggest source of pharmaceuticals in our wastewater is from our human bodies. And with the wastewater treatment process, it is primarily, in many cases, a biological process, and these microbes. And there are a lot of studies that are investigating, how much of these pharmaceuticals the microbes can ingest. But in cases that at the end of a wastewater treatment process, that uh, pharmaceuticals at these very low nanograms per liter doses, can work their way into the treated water being discharged from a wastewater treatment plant. Say if you lived near the Mississippi River, that water, that treated wastewater, uh, could end up in a surface water discharge into the Mississippi River, and then you will have these very low levels of pharmaceuticals in that surface water. So that's one way that pharmaceuticals can get into our environment.
Okay, I just want to clarify one thing. So, some of our listeners, they will have no idea what goes on at a wastewater treatment plant. They may never have seen one. So, you mentioned microbes that may or may not have the potential to ingest and break down these pharmaceuticals that end up in the wastewater. And so, what we're referring to there is microbes that are used in the biological treatment process that you mentioned earlier that happens at wastewater treatment plants. So, at a municipal wastewater treatment plant, there's typically some type of they call it digestion, and that is a process that uses microbes to break down what's in the wastewater. Usually, it's to bring down the level of
for the viruses and pathogens.
Pathogens, yes. So it's to bring down the level of pathogens that are in our wastewater that come from our poop. Um, so I just wanted to point that out, and hopefully I'll get somebody who's more of a wastewater treatment expert onto a future episode, and we'll go into that even more. But yeah, thank you for going into that with us. And then there's other types of emerging contaminants of concern with drinking water. Could you tell us about some of those?
Well, in what you might see, for example, um, say if somebody is taking a heart beta blocker drug, and it may have atenolol in it, and that could end up in the wastewater that goes to the wastewater treatment plant. It potentially could not be taken up by the microbes in the wastewater treatment process, so then it ends up in the discharge from the wastewater treatment facility. So again, like with the Mississippi River example, that water, if it's discharged to a surface water, then the next city downstream, if their source of drinking water is that same surface water, then at these very low levels, you could see, in this case, the atenolol in the surface water that's entering the facility, the surface water treatment facility. So the good news is a lot of these advanced water treatment processes will destroy the bonds that hold together the chemicals that are within these different pharmaceuticals, and make the water safe to drink. The concern is that the older, say some of these older surface water treatment facilities that don't have advanced treatment processes, that so those older processes may not be able to remove these very low levels of pharmaceuticals that are, again, starting in the surface water, that source of water supply for the treatment facility.
Okay, interesting. Thank you for explaining that. So I'm going to switch gears now, and I want to ask you, what is the most interesting project that you've worked on, or maybe even the one that you feel like you got the most gratification out of working on?
Well, there's so many, which is the beauty of this field. Let's see. That's a very good question. I mean, I think probably the more challenging projects have been when you pull together uh, your knowledge from all other types of projects, and then you apply it to something new. So it may be um, there's there's maybe there's an asset that an electric company has, um, and you've got to find a way to, and they, they want to, they want to sell it and maybe use it for for a public utility. And so, just trying to determine, what regulations apply to this process, what types of technologies exist to complete this project, what is the cost, budgetary cost to get this done, and does the client, do they, within their capital improvement program budget, do they have the funds where they could make this project happen? So I realize this is kind of a vague answer, but just pointing out there's just so many things in this field that keep coming up, whether it's integrating, say, solar into a wastewater treatment plant or in a water treatment plant, trying to offset the energy for running a pump with, solar panels. So, yes, it can be a little bit of anything, which for I don't know, for me that works great, and I'm a big proponent of consulting because of that.
What would you say you find most gratifying about your work?
Knowing that day in, day out, that the projects that I work on with a team of people, that we're working with our client, and we're making sure that we're getting safe drinking water to people, that we're properly treating wastewater that has been collected from people's homes, that we are looking forward with um, changes in the environment. We Within the Tampa Bay area, we are seeing areas experiencing sea level rise. So developing solutions to address protecting the assets of private and public utilities, of the government, and um, you know, so we make sure that we're uh, protecting those assets, that the capital monies are being spent wisely, that we're coming up with solutions that are cutting edge. So it's just, it really, the sky is the limit because of the needs of this environment.
And that leads well into my last question. So, do you have any recommendations or specific advice that you would give to somebody who's interested in going down the environmental engineering path?
Well, I would say if you have an interest in the sciences and and these are, earth sciences. These are, the biological sciences, mathematics, geometry, calculus. I mean, any of those areas. Um, really focus on that. Um, you don't have to know everything. I mean, there are. I have friends who just excelled in diving into the details, and they love research, and they were made for getting their masters and PhDs. So that worked great for them. Um, for somebody like myself, I do have my master's degree. It is in engineering management. So my track is more along the lines of engineering management. I love working with people and managing projects. It's kind of a puzzle, managing projects with getting the design done, making sure you're staying on budget, and you're coming up with new ideas to um, make it a good project at a good price. So just for uh, the audience that is you know looking for the signs, I guess I should say, is just if there's something that you just love, go for it, and you're going to find that niche. We need all types of people to make this type of, or to complete these projects. So yeah, definitely stick with it.
That's absolutely right. There's a whole lot of steps and lots of different types of expertise that go into executing a project, from conception to design to building it. So that's great advice. Thank you so much, Emilie, for coming onto the show and sharing your career path and your advice with us.
Oh, my pleasure. Thank you very much.
Hello again. I'm so glad you made it here to the end with me. Thank you again for downloading and listening. So, as I mentioned, this is the third in our series on water and wastewater careers. I'm working on getting several other specialists onto the show, one in stormwater, hopefully one in municipal wastewater treatment, and then there are a couple wild cards I'm also trying to schedule. So a woman that specializes in industrial water treatment, and also a lady that has extensive experience in holistic regional water management, like over multiple municipalities. We're far enough in now that I'm ready to tell you my next series here on STEMxm is going to be about climate change careers. So I've started to line up some women that specialize in different areas of climate science, and I've already started recording those, and I can't wait to release them. So thank you again for joining us today. You can find this episode's show notes in the usual spot at STEMxm.com/episode 19. That's STEMxm.com/episode and then the number 19. Remember, you can get in touch by reaching out on our Facebook page, which is at facebook.com/STEMxm, or on Twitter, where the handle is just STEMxm Podcast. Thanks again, and I'll chat with you in episode 20.
This has been an episode of the STEMxm podcast. Thank you for listening. We would really love if you could pop over to iTunes and give us an honest, positive rating. It helps more listeners find us to learn about STEM careers. Thanks again, cheers, and we'll catch you on the next episode.